What would you do if an extraterrestrial intelligence contacted you? Of course, after you checked all the expired food in your fridge, you'd probably be baffled by this attempt at contact. Astronomers were recently puzzled by a similar attempt. Let's break it down. We're talking about mysterious signals from space with no specific sender, and also about fast radio bursts, whose name is hidden under the abbreviation fast radio bursts. Fast radio bursts. The latter are striking for their persistence and duration over time. After all, the first signal was detected about 10 years ago. We have received approximately 40 radio bursts, the most recent of which was recorded relatively recently. Let's start with the basics. What method did humanity choose to receive possible signals from extraterrestrial worlds? After all, you can't just tune in to some 104.5 frequency modulation and hear,
"Hello, this is Alpha Centauri speaking."
No, everything happened in a much more prosaic way. One day, two very smart people got together, Cocconi and Morrison. The latter was an American astrophysicist who worked at the Massachusetts, California, and Cornell universities. By the way, his academic advisor was none other than Robert Oppenheimer, the creator of the atomic bomb. So, after some time, scientists came to the conclusion that the frequency of free hydrogen is just right for receiving extraterrestrial signals. This most common element in the universe emits at a wavelength of 21 centimeters and easily penetrates seemingly opaque clouds of cosmic dust. Astrophysicists decided that any advanced civilization would have known about this for a long time, so they would also transmit and receive signals at this frequency. But the calculations turned out to be too optimistic. In half a century, we've received very few messages from outside. One signal went down in history under the name WOW. It was received in 1977, lasted 72 seconds. But there are still debates about its possible earthly origin. In fact, it even got ridiculous at times. Some theories suggested that someone in the lab turned on a microwave oven while the Big Ear telescope was operating. However, regardless of that, the signal completely matched the expected characteristics of extraterrestrial emissions. In addition to the aforementioned attempt by extraterrestrial intelligence to contact us, if it really was them, science is also aware of the radio signal SHG-B02 plus 14A, detected in 2003 by search for extraterrestrial intelligence participants like the WOW signal. It remains the top candidate for artificial origin. If we are dealing with a session of extraterrestrial communication, it turns out that in this case, the unknown beings were persistent, since they tried to do this 3 times. Each signal lasted about a minute, again, at the frequency of neutral hydrogen. Where did this signal come from? This is where things get really interesting. Thousands of light years from Earth, between the constellations Pisces and Aries, lies a void, an empty region without stars or planets. And now, attention, here's the question. What or who sent the signal from this area? The second amazing feature is the frequency of the signal. It changed incredibly fast. If such a transmitter were installed on a planet, then this object would have to rotate 40 times faster than Earth. And yes, the pulse never deviated from the hydrogen frequency. All 3 times it was heard exactly on it. No chaos, only orderliness. What do astronomers think about this? There are many theories, and not all of them are related to hypothetical extraterrestrials. A malfunction in the Arecibo telescope is being considered. Some astrophysicists also believe that we are dealing with an unknown cosmic phenomenon of monstrous scale. However, this signal has not repeated in 20 years. Just listen to how strange and uneven it sounds. Don't you think that through the static you can hear sounds that resemble voices? Maybe back then in 2003 someone was trying to reach out to us through the veil of light years and warn us about the hard times that would soon come to Earth. Who knows? But did it really end there? Not at all. After the arrival of the new year, 2023 astrophysicists once again detected a signal on the frequency of free hydrogen coming from the Galaxy Sloan Digital Sky Survey, J0826+5630. It is incredibly far away, 8.8 billion light years from Earth. That means the light from this object started traveling 5 billion years before our planet was born. The signal was picked up by a huge telescope located in India, in the state of Maharashtra. It's amazing that before, we only got signals from nearby galaxies, but this time, it's from the heart of the universe. However, in this case, the gravitational lensing effect came to the rescue, which amplified the signal many times, allowing it to reach us. The thing is, there was a massive cluster of stars shining near the path of the cosmic message. It helped deliver the signal. What else is known about fast radio burst signals, or fast radio bursts? Actually, we know very little about them, although scientists are actively continuing to study these phenomena. Such radio signals often come from deep space, so we can only guess about their sources and origins. But considering the repeated occurrence of some bursts, their catastrophic nature had to be excluded from the list of assumptions. For example, as part of the Canadian experiment that took place from 2018 to 2038, radio bursts were recorded and everything would be fine, but some of them were detected not sporadically, but with enviable regularity. Let's take the legendary signal fast radio bursts, 18,916-J 0158 plus 65 as an example. It repeated with varying intensity once every 16 days. Researchers from the Canadian Hydrogen Intensity Mapping Experiment collaboration observed this process for more than 400 days in a row. The second amazing aspect discovered as a result of fast radio burst research is their extreme energy. In just a few milliseconds, they release energy equivalent to hundreds of millions of suns. What kind of cosmic monster could have produced such signals? It was previously believed that certain periodic patterns were caused by traces of activity from black holes and the stars orbiting them. Where did the still unexplained radio burst, fast radio burst, 18,916-J0158 plus 65 come from? The source is located 500 million light years away from us, in a galaxy at the star formation stage. Right now, this object may already be dead, since its light traveled to us for 500 million years. But even that we can't know for sure. In such matters, helplessness is humanity's middle name. Some in the scientific community suggest that it could be a magnetar or a pulsar emitting in the X-ray range. But those objects oscillate much faster, not just once every 16 days. There have also been hypotheses that this radio signal is part of a larger cycle that we are not yet able to detect or understand. One thing is clear: chaotic and repeating fast radio bursts are two different types of bursts. Humanity has always strived to see what is happening in deep space, but sometimes it can also be heard with highly sensitive equipment. It's also important to understand these signals. Who is trying to tell us something, and what are they trying to say? Or what event of unprecedented scale could have produced such powerful echoes. That's why the A sign in Space Project was created by the same search for extraterrestrial intelligence. The essence of it is that ordinary people are given access to raw data collected by several telescopes. They're fully encrypted, and opening these files isn't easy. But that's not an issue. Scientists at the Institute for the Search for Extraterrestrial Intelligence have given participants a manual to study independently. Only after the user learns how to use the interplanetary file system can they begin to study the information provided by the telescopes. This seems like a great way to feel like a complete idiot. But seriously, maybe someone really will decipher an alien signal, discovering a plea for help or some kind of threat in it. Meanwhile, humanity will realize the real problem isn't their location but something else. We don't know how to interpret signs from outside because they come with no instructions. That's why we shouldn't categorically claim that other civilizations haven't tried to contact us. Maybe we just didn't notice it? And what about the letters to nowhere that humanity has repeatedly sent aboard its probes? If we imagine that somewhere thousands of light years away there's an intelligent civilization, when will our message reach them? Will humanity still exist in the 31st or 41st century when the answer arrives? These are serious questions because distances in space are no joke. How much do you know about Mars? What do you think about when you look at an image of its surface? Do you think there's nothing on the red planet except rocks and the same dusty landscapes? However, that's far from the truth. And now you're watching a real dust storm somewhere on the horizon. It becomes so powerful that its destructive force covers not just some area, but the entire planet. And Mars can't forget about this storm. After all, it occurs every 5.5 Earth years or every 3 Martian years. Dust covers absolutely everything with a dense layer and blocks access to sunlight. But what does all this have to do with us? Well, first of all, if we send our research probes to Mars, they will quickly break down in such conditions. And of course, if we plan to colonize the red planet in the future, we'll have to adapt to such massive sandstorms. And at the moment, this would be difficult for us because we don't know why these storms occur at all or why they happen so regularly. But what are the consequences of this, and what should you do to survive during a Martian storm? First of all, it's worth noting that the red planet used to have a different atmosphere and possibly even water. So dust storms of this scale couldn't have happened back then. Over time, Mars became an inhospitable desert planet where the atmospheric layer has essentially eroded away. Now, the atmosphere on Mars is less than 1% of what our planet has. Of course, that's not the only reason why storms formed on Mars. We can't say for sure yet, but most likely, the temperature of the planet turned out to be a pretty significant factor. As the atmospheric layer kept getting thinner, Mars could no longer retain heat as well as it used to, and so the planet started to cool down. In addition, there are also huge temperature fluctuations on it. It ranges from 27 degrees Celsius during the day to as low as minus 133 degrees at night. Because of the temperature fluctuation, strong winds form on the planet. And for Mars, it's not so much rain cycles that are typical, but rather dust cycles. How does dust even get into the air? In summer and spring on Mars, so-called dust devils form, whirlwinds that redistribute dust particles. When the sun's rays heat the surface, the air at the very bottom rises up, while the cold air sinks down to fill the void. All this contributes to the formation of spirals in the air, which sometimes reach a height of 8.5 kilometers. As these spirals move, they absorb everything in their path, and they encounter a huge amount of dust, which they then leave behind in the atmosphere. When this happens, the sky on Mars appears much darker, and the dust remains in the atmosphere for a long time. There are other options as well, the most common being the actions of the winds. It's quite difficult to move dust in the air on Mars. because its particles are electrostatic, and let's say they often stick together. So it's very hard to separate them. To make Martian dust particles move, you need an impulse. It's quite easy for gusts of wind to lift larger particles. Even though at first glance it sounds paradoxical, the thing is, larger dust particles don't stick together as much, so the bigger particles get lifted into the air. They can't stay up for long because they're too large, so they fall back down after traveling a short distance. When they fall, the impact breaks the strong bonds between dust particles, allowing the smaller ones to be lifted into the air. There, Mars's gravity is weaker, which means the dust can stay suspended like that for weeks or even months without settling. That's what allows strong and long-lasting storms to form. Dust particles retain the heat from the sun quite well, and when these particles heat up, they start to release the accumulated heat into the atmosphere. And then the warm air rises, just like it does with dust devils, but on a much larger scale. This leads to greater salinization of the Martian soil, more dust being lifted, and therefore increased heating of the atmosphere. The result of all this is the formation of a dust storm. If a Martian dust storm rages only in one area, it doesn't pose much of a threat. Its speed is usually about 97 kilometers per hour. The speed of Earth's hurricanes is half again as much. And because of the thin atmosphere, it's not really that noticeable, and often it can't damage a research probe in any way. However, there are always exceptions. If a dust storm contains a certain amount of slightly sticky electrostatic dust, when it settles, it blocks access to sunlight, and that's very bad for devices that run on solar panels. They simply don't get any energy. The number of problems increases as the storms get bigger. In spring and summer, the southern hemisphere of Mars is closest to the sun, making it the warmest region on the planet. And during this period, for reasons we can't yet explain, dust storms begin to merge into one massive storm. Of course, this could be because they were simply close to each other, but it happens with surprisingly precise regularity, which is unlikely to be a coincidence. How do planet-sized storms form on Mars? Scientists still don't have an answer to this question. They occur once every 3 Martian years, and that's not enough to explain it, even with Milankovitch cycles. The time intervals there are much longer. There is a theory that this is one of the stages of the dust cycle, but we can't say for sure. Usually dust storms on Mars last for several days. However, these giant storms can persist for weeks, and accordingly, this will negatively affect our research devices. An important factor here is the aerosol optical depth, which shows how much sunlight is available. This value should be less than 2 so that our devices can be charged using solar panels. Usually on Mars, this value is 0.5, which is within the normal range. When huge Martian dust storms occur, it ranges from 9 to 11, meaning no sunlight gets through at all. That's exactly why the Opportunity rover mission failed, because its solar panels were completely covered with a thick layer of dust. This led to a serious malfunction of the rover, and that doesn't mean that spacecraft with nuclear batteries are safe in this case. Such large-scale storms can simply disrupt communication, causing the rover to be unable to receive a signal from Earth. Moreover, even satellites are at risk. Because of the huge amount of heated dust, the atmosphere starts to expand, throwing some of it into orbit where satellites usually operate. Because of this, they have to change their trajectory, spending a huge amount of energy. Just imagine that you are already colonizing Mars. Solar panels won't help you, and while the dust storm is raging, you most likely won't be able to contact Earth in any way. You need to come up with something so that you can be self-sufficient for a certain amount of time. Interestingly, such massive storms actually destroy themselves, as strange as that may sound. That's because they block access to sunlight, which stops the winds that lift dust particles into the air. And then after a while, Mars becomes quiet, inhospitable, and lonely again. but soon it will be covered by another planet-sized storm. The last one happened in 2018, which means the next one will occur very well. And what do you think? Will we ever understand the nature of such a phenomenon? And how will we deal with it if we colonize Mars? Galaxy. You hear this word quite often, especially on our channel. You already have a complete image of it in your mind, and most likely you imagine a spiral galaxy like this. Galaxies can be very different, yet all are equally interesting. So what is the true appearance of these amazing cosmic structures? We are familiar with the spiral type of galaxies. They are somewhat similar to a whirlpool that forms when water drains in a sink. Most of the galaxies we know are spiral. For example, the Milky Way or Andromeda, the large galaxy that is closest to us. But what about other types? What kinds are there? Several decades ago, scientists believed that our Milky Way was a unique structure, meaning the only galaxy. Back then, they knew about Andromeda, but believed it was just a nebula in our galaxy. Everything was changed by the American astronomer Edwin Hubble. Through his mathematical calculations, he discovered that Andromeda was not a nebula at all, but a galaxy just like the Milky Way, containing trillions of different stars. This discovery made scientists reconsider their approach to defining such objects. Currently, there are about 2 trillion galaxies in the universe. Edwin Hubble in 1936 created his own classification of galaxies by their shape, which is now called the Hubble sequence. In addition to spiral galaxies, Hubble also identified barred spiral galaxies, elliptical, lenticular, and irregular galaxies. They are also called irregulars. The scientists believe that the type of galaxy determines its future, how it develops, and what it can transform into. Let's start with something more familiar to us: spiral galaxies. Such objects can be considered relatively flat, except for the so-called bulge in the middle. This is the brightest part of the galaxy, and it's also denser. The bulge typically holds a cluster of older stars. Because of this, the color in this area is more yellowish. But at the edges, blue stands out. Why does this area stand out so much? There is a theory that such a concentration formed because of the presence of a supermassive black hole there. The spiral parts are called galaxy arms. Usually there are 2, but sometimes more. It is in these arms that there is a high concentration of stars, and accordingly, more active star formation. The arms usually point in one direction. If this is not the case, then most likely the early galaxy collided with another galaxy. The bulge also surrounds the area called the galactic disk. Most of it is filled with gases, stardust, and young stars. There is also a spherical region, an invisible component of the galaxy called the halo. It extends beyond the visible part of the galaxy. Most of the halo is most likely made up of dark matter. It also contains clusters of stars and rarefied gas. The halo may also contain remnants of long-dead galaxies. It is also worth noting that the density of the arms can vary from galaxy to galaxy. If the arms are denser, their arrangement helps to see the central part, the bulge, much more clearly. So what are barred spiral galaxies? They are more elongated compared to regular spiral galaxies, and they also have a bar where stars cross the galaxy through its center. The galactic arms actually extend out from this bar. Otherwise, these objects are very similar to spiral galaxies, and now we know that about 2/3 of spiral galaxies have this bar, and the Milky Way turned out to be one of them. Next are elliptical galaxies. At first glance, it may seem like this is an ordinary, albeit giant star with a distinct bright center. Most of the space in an elliptical galaxy is occupied by older stars, which gives the object either a red or yellow color. Since there is usually a tiny amount of interstellar gas inside such galaxies, young stars hardly ever form there. There are galaxies that are not compressed, and there are galaxies with a very high degree of compression. According to this criterion, elliptical galaxies are divided into groups from E0 to E7. E7 is an ellipsoidal shape, while E0 is almost a perfect sphere. The sizes of such galaxies can vary greatly. Some can be dozens of times larger than the Milky Way, while others can be dozens of times smaller. Lenticular galaxies. Simply put, this type combines the characteristics of spiral and elliptical galaxies. These galaxies have arms, but they are almost unnoticeable. Moreover, new stars are hardly born there due to a lack of stellar material. Most of the stars there are old and are yellow or red in color. At the same time, lenticular galaxies, like spiral ones, have a flat disk and a bulge. It is believed that about 20% of the galaxies in the universe can be classified as this type. Let's move on to the most interesting part, irregular galaxies. Why are they called irregular? Simply put, because they don't resemble spiral, elliptical, or lenticular galaxies. These galaxies don't have any specific shape. In fact, they're just a cluster of stars brought together by gravity in a random arrangement. Some irregular galaxies don't even have a defined center, but they're also extremely rare in the universe. These galaxies make up only 5% of the total number. But what caused such strange objects to appear in space? We can't say for sure, since there could be many reasons for each galaxy. Most likely, such a galaxy used to belong to other types and looked quite ordinary. For example, some destructive processes could have occurred in it that significantly changed its shape. Or perhaps the galaxy simply collided with another one at some point. In some irregular galaxies, you can still make out its previous shape, and some don't resemble anything specific at all. Ring galaxies can also be classified as a separate type. They have a core in the center. However, after that, there's nothing, just emptiness. And then a ring begins which directly surrounds the core. This ring is made up mostly of young stars. For example, Hoag's object in the constellation Serpens is a ring galaxy. Of course, galaxies can also be classified in other ways. For example, there are also dwarf galaxies, which are much smaller than regular galaxies. However, now we know the main types. And here, an interesting question arises. How did humanity even figure out what shape our galaxy has? In 1785, the British astronomer William Herschel decided to find out what our galaxy looks like. To do this, he created a special map with all the objects known at that time, which were supposed to be in our galaxy. At that time, he was far from the real picture, but it was the first attempt. The beginning was made. They revisited this question only in the 20th century. The American astronomer Carl Shepley determined the distance from the solar system to the globular clusters orbiting the center of the Milky Way, which helped him conclude that we are located somewhere in the outer region of the galaxy. But William Herschel thought that our sun was at the center of the Milky Way. If we look at the starry sky from Earth, we can observe a band of stars. This is part of our galaxy. This is what helped determine the possible shape of the Milky Way. Spiral or lens-shaped? To know for sure, it was necessary to determine whether the galaxy has spiral arms. Radio telescopes helped astronomers create a galactic map, and the first one appeared in 1958, where the spiral pattern was clearly visible. Unfortunately, much about the Milky Way is still unknown to us. The galaxy still holds many secrets. For example, we still don't know exactly how many arms the Milky Way has. And what do you think? What other interesting things might we learn about galaxies in the future? And is it possible for scientists to discover another special type that we haven't observed before? Mars, the red planet. For many years, it has attracted scientists from all over the world who are doing everything possible to learn more about such a mysterious planet. Today we will talk about the Perseverance rover mission and show you the pictures it has taken during its time on Mars. What interesting places are there? What does the sky look like? And what unique things have we been able to see thanks to the rover? The main goal of Perseverance is to study the planet's past geology and climate, collect Martian rocks and regolith, and also search for ancient microbial life. This is the very first high-resolution color image sent to us by Perseverance after its landing on February 18th, 2021. And here is the very moment of the rover's landing. The photo was taken by a camera on board the descent module. And here are the images we received using the Sherlock Watson camera, which is located at the end of a special robotic arm. Here we can examine the rock formations in more detail. The right Mastcam Z camera helps us with this. This is better than space movies. And what does the sky look like on the red planet? Perseverance captured something truly unique with its camera. The sun is being eclipsed by Phobos, one of Mars's moons. This is the most detailed high-frequency observation of a Phobos solar eclipse ever made from the Martian surface. For example, Perseverance is taking a selfie here. And here it is already moving straight ahead. Here you can observe real dust devils. Strong winds that formed near J0 crater on July 20th, 2021. What we observe on Mars with Perseverance is a reality that was previously inaccessible to us, and we have no doubt that the rover will prove itself even more. What do you think? What else interesting can we discover on Mars? And for now, as a final note, enjoy more images of the red planet.